let's talk first about the current practices in the construction industry. So I think it is well known from our experience. We know that currently there is excessive waste, there is very low profit margins, there is major risk, and the overruns in budget and schedule is the norm instead of the exception. And at this time, I would like to introduce a poll so that we have the context of our discussion and we are able to better relate later on during the discussion. I don't see the poll, Dr. Luai.
Theo, you didn't share your screen, or it's shared? Okay, I will start the poll now.
Yes.
We have very few responses, so you are all encouraged, please, to participate with the polls. Yeah, we are getting more responses now, which is great.
Yes.
So far, only 30 persons responded out of 90 persons attending. So please, we need your, yeah, we get now higher engagement. Thank you for those who participated. I will give it a few more seconds to encourage the rest to answer these questions.
Shall we go ahead?
Okay, so I will end the poll now.
Very good. So from what I can see, there's a good portion of the audience who have engaged with BIM in their projects, a little bit lower percentage who have had lean construction tools. And in general, there is a good experience with using BIM and lean. And that's very good to hear. And I hope that we will be able now to better relate to the material of the webinar. So let us progress again on the same context. The traditional environment, the current environment, as is traditional in the design and construction industry, is fragmented. And we know this. The communication is very difficult, death by meetings. We have to constantly communicate. And you can see, as you can see the diagram, how difficult it is to cascade the decisions taken from some of the stakeholders to the rest of the stakeholders in time, so they are able to perform their duties. Also, it is well known that the project deliverables and the handover documentation, which is handed to the operator or to the client at the end of the project, is most of the time paper-based, inaccurate, and of low quality. Not always, but this is the norm. We know that the as-built drawings are done in a haste, and many times they depict inaccurate geometry. They don't really show the as-built conditions. The operation maintenance manuals are based in some cases with disorganized information, with low quality or low resolution scans, and they are of little connection to the as-built drawings. And also there is one other parameter, which is the information loss. that we encounter during the project stages. And as you can see in the diagram, there is substantial cost and time impact on the information lost. And this is while transitioning from one stage of the project to the other, it is different stakeholders and different understanding of the project and different expectations. And the way that we currently work, we codify the information in hard copies and in a way which is inefficient and difficult to be used in the next stages, and it needs very experienced users to be able to translate them into meaningful information. So if we may present the current construction ecosystem, you can see that for the same project, for the same similar expected result, we engage different stakeholders, different contractors, different material, and different manufacturers, and we end up with different results. So this is a highly complex, fragmented, and very project-based construction process. And as per the statistics from UK and US and in other countries, it is well known that there is substantial rework up to 30% of the total construction cost. The labor is utilized between 40 and 60% efficiency. At least 10% of the site material is wasted, and accidents often equal up to 3 to 6% of project cost. So it has been calculated that up to 50% of the total cost of the projects is waste. And to put also an environmental parameter, this is affecting the environment. Just to say about the 10% of the site material wasted, just the transportation of material for construction is equal to 10% of the global CO2 emissions on a yearly basis. So it is evident that we need to change, and how we construct needs to change so that we can meet the needs of the emerging digital era, we can minimize the impact to the environment, we can maximize the use and value of the resources, and we can provide an economic viability and sustainability to the construction sector. And you can see this very nice sketch at the bottom. We are sometimes very busy to see the solutions which are right in front of our eyes. In this case, this is BIM and Lean. And just to get now a little bit more detailed regarding BIM, which is the essence of our webinar today. BIM, contrary to what many people believe, is a process. And we all know the, of course, if we Google BIM definition, we will get a definition from the United States National BIM Standard, which says a digital representation of a facility, and etc., etc. However, this is not just a model or a 3D, and this is a shared knowledge resource which can be used from the inception of a project until all design, construction stages, operation, and finally to the renovation or the demolition. And in fact, we should define BIM more accurately as not just a new software tool, but a transformational approach to business and organizational mission, which includes a new way to work with multiple people together in real time. And this is the strategic use of information technology and BIM by integrating data, information, control, and processes. So collaboration is the #1 rule, which is exactly the same like Lean, of course. And at this point, I would like to define what we usually say BIM, where it might mean building information modeling, it might mean building information model, and it might mean building information management. And I will explain very briefly those terms. So when we speak about modeling, we speak about the business process for generating and leveraging the building data to design, construct, and operate a project, a building, right? When we talk about the model, this is the digital prototype the computer model which holds the information in a structured way. So information about design, about quantity, time, cost, etc. And as you can see, with intelligent input, we are able to extract the whole project documentation, for example, specifications, production details, shop drawings, class detection analysis, schedules, visualizations, etc. And finally, building information management, which is the higher form, if I may say, which is the organization and control of the business process using the digital prototype to affect the sharing of information over the entire life cycle. And when we say information, we don't just mean graphical, but also non-graphical and documents. And of course, BIM is now defined by a number of international standards. There used to be British standards, 1192 series, 2 to 7, which are now partially overwritten by the ISO standards. So ISO 19650, 1, 2, 3, and 5 are already published, and they define the concepts and principles, the delivery phase of the assets, the operational phase of the assets, and the security, the digital security, which is part, of course, of the information management. And of course, this is now the time where national annexes can be developed to further detail these ISO standards to make them applicable for each country and the context of each of their construction industry. Very quickly, just a term which everyone uses in their everyday interaction with BIM, which is LOD. Just to say quickly, LOD definition is the US approach, which has now been adopted worldwide. So we tie the need for information with a need for visualization into 5 stages, if we can say, if we can put it in this way. So we have LOD 100 up to 500. So LOD 100 being the concept, the equivalent of concept design, LOD 200 the equivalent of schematic design, LOD 300 the equivalent of design development, 350 the equivalent of IFC, 400 the equivalent of construction stage documentation, what we call here shop drawings, and finally LOD 500, which is the equivalent of the as-built. And just to give a very brief overview, so you can see how the visualization, but also the information, which is marked in red letters below, changes from one stage to another. So you can see from concept, which might be just a rough volumetric model, up to finally the as-built, which has to be the actual component used with all the details, not necessarily furniture, of course. This applies to all BIM aspects. And the document that we mostly use to communicate these requirements is this guide from BIM Forum, which is called LOD BIM specification. And as you can see, both visually and also with details, context, it provides guidance on what is the expected visualization and information to be included in the model in each component in each stage. And something very important, which I feel has to be the first slide, and it is related to the common data environment. Maybe some of you have a common data environment in your projects or in your companies. This is the basis for BIM implementation. It cannot even be called BIM, in my opinion, if we don't have a common way to communicate the information. And of course, this is of paramount importance. Always the latest and the valid information is available to all stakeholders real time. There's a much faster coordination and review cycle, obviously, because all stakeholders save the information at this common data environment, so everyone can get alarm or get notification wherever new information become available. Search time is drastically improved, and the filtering is very easy. Documents have attributes, obviously, and this is the way we use them. Metadata, you might have heard this. We can create, upload, share documents in seconds. We can create workflows which allow the team to work collaboratively. And finally, there is a review and approval status which follows each document. So it might be work in progress, shared, published. It might be even described as fit for certain operations or different operations at a time. And let's discuss at this point what we call the BIM dimensions. You might have heard, of course, 3D, 4D, 5D. Just a very brief explanation. 3D refers obviously to the visualization. 4D refers to the time, where we are able to link the time parameters, the scheduling into the model and create maybe a construction sequence. 5D, when we can include the cost information in our model and in our construction sequence, in our visualization, cost or quantities. 6D is related to operations and attributes needed to operate an asset. 7D to sustainability, and lately 8D is linked to safety, although these terms are sometimes interchangeable. Up to 5D, it is very well known. However, up to the rest is maybe you will hear different opinions about their meaning. And I think now I can give a pass to Nikos to continue with more details about the BIM implementation, starting with the design software and how nowadays design is really integrated with the model, right, Nikos?
Yes, Fanny. Thank you very much for the very good introduction on the regulations that there are in the market. What I'd like to discuss here in this session, since we're talking with the Lean Construction Institute, is about 4 key elements, which is contracts, procurement, people, and the tools. Now we have the slide of the tools here. You see that the current market has been flooded with different tools, different functioning. So it's paramount importance to understand the use of each tool and to optimize it on the use of each project. This will enhance the productivity, will enhance the understanding, and will enhance the whole infusion of the BIM in the whole processes of and the requirements of a project. It's not only design; it's about how you manage the whole situation. So if you want to go to the next slide, everybody is aware of these platforms. Of course, documentation, automated drawings, and extraction is something that we want and we pursue, utilizing automated tools like visual programming, and I want to refer to specific platforms like Dynamo, which are done to specific platforms again. But it's something that we want to pursue, and we want to enhance the attributes of the models to become smarter. So we want, Fanourakis, we want to pursue to go to the next level. Next slide, please.
Sorry, Nikos, we have one comment about the sound. If
yes.
You can, at my end, the sound is clear, but if you can maybe bring the mic closer, or
yeah, of course.
Yeah, that's appreciated.
Right.
Thank you.
Very good. So as I said before, in the design process, we try to enhance the use of visual programming, possibly enhancing the quality, minimizing the human error factor. So it's something very important, and we think that it's a lean process where we're trying to streamline the whole thing in a common environment. So Fanourakis, can you go to the next one, please? Of course, we want to do our checks, our quality assurance checks and validation using automated tools. like using utilizing specific and particular softwares. If you want to go to the next one, Fanis. Now, in terms of coordination, we know that all the projects nowadays are very complex, especially in the region of the Middle East, are really complex. We've been in the region for many years. We know very well all the projects, what the requirements and what they need. So coordination is paramount. It's of paramount importance, and how we can enhance the whole process in order to have a class-free design. And of course, one of the key elements on this is one of the 4 factors I said. It's the procurement, it's the materials. We have seen that most of the time is being wasted in the projects among members when the materials and the material submittals are not approved on time. That means that the whole process of the BIM and the effort that we're putting on creating the drawings and creating all the coordination of the designs has been wasted because of procurement purposes. Of course, constructability studies is something that is very important, and we perform during the coordination period and to increase the interface to the interfaces, the effectiveness to the interfaces. We're trying to link all the information of the BIM, of the rooms, materials, different elements. We want to bring everything in one picture, in one database, so it can be used by the end user effectively and successfully. Of course, we can use the BIM as well for visualization purposes to increase the understanding of people that they're not very familiar with the spatial arrangement of the building, of the structure of the project. One of the biggest goals that we have seen thus far, Fanny, if you want to go to the next slide, please. One of the biggest goals is the use of the 4Ds, and of course the use of tablets on site, and the use of management tools on site. So the biggest and successful achievement that we had all these years is to create a culture in the people that they have to rely on the model, and they have to go to the model to get the most of the information, of course, to enhance the reporting. Next, please. So this is, you have to speak, I think.
Yes. So I think sometimes we discount the visualization. However, I think it is a very important aspect. And I will just give this slide as a sample, how we can very efficiently define the scope and the work packaging in very complex projects. And I will show another example here where you can see how many different components and interface points between different companies, different suppliers, different engineering companies, in order just to produce one component of the project. So really, in these cases, having the 3-dimensional model and the, the transparency and the clarity that it brings is very important, and sometimes it is discounted, but it should not. I think we lost Nikos.
No, I'm here.
Okay, so go ahead, Nick.
Yes, now about 5D quantities and costing, it's another aspect. Now all the contracts have been more regulated compared to 10 years ago that we have started using the BIM in the design in the Middle East. When we started, there were no regulation and there were no code, so we were relying on the individual effort, endeavor of everybody to perform some BIM principles in the projects. Now we have this; it's more regulated. So all the key important and very important thing is that we have all this information in the contracts. One of the key elements is the 5D quantities. This has been regulated. Now software we have, so we have more efficient methods of extracting the quantities and linking and cost loading the programs. By having this 4D quantities and the forecasting, we can do all the VEs and VOs, studies, we can check revisions, etc., etc. scope and quality comparison. Of course, this is a very key element, especially in particular traditional contract projects, not design and build, where we see different designs coming in from the clients. With a very good tools now, we can compare and we can see the differences, we can quantify the differences, flag them, and we can proceed on with the process that has been stipulated in the contract. From another point of view, from another aspect, we have, in many projects, we have long lead items that are influential in the design, influential in the construction, and has to be on the right time on the project. Always through BIM, we can check through sweep path analysis and through simulations, we can check those elements that can be on the right time, on the right place, without disturbing the surroundings, without disturbing the building and what has been built on site. Another very good example of the BIM in the construction is about arranging the site, arranging the cranes, the laydowns, stockpiles, and all the construction logistics. So we can utilize even the power of the laser scans. Fanny, if you can do that, yeah, of course. So we can utilize the power of the laser scans, and we can overlay with the design, so we can see, we can proceed, and we can see the various issues we might have on site that they're not picked up from a model, a single model. So Fanny, next. Value engineering, it's a key thing. Of course, it's more important when you do it pre-construction, when you do the tendering, to have all the issues of value engineering being approved, etc. But anyway, during the construction, we could potentially optimize things. We could enhance things, and through BIM, we can increase the understanding. We can extract quantities. We can pursue better designs, and so we can have better results. Of course, construction methodology are enhanced by visualizing the stages of erecting things, of proceeding on the next steps. Funny. This is an example from one of the stadiums, how we could visualize the erection of the tension compression ring. Again, this is an example from another project where it was visualized the methodology and the stages of erecting complex steel structures, trusses, very heavy, requiring very special equipment, and it was a very good effort on this. Fanny?
Yeah. Of course, there is now another, if I may say, a tool, very powerful tool, laser scanning. Process, even I might call it. The point cloud is the resulting, and which we use increasingly in our projects, actually currently in all our projects, to verify the construction, the actual construction geometry, right, and details. And as you can see, for example, in this case, we can find the deviation between the as-built and the design model and the expected design. We can quantify it and verify it. In some cases, we might find, of course, completely different as-built condition than the expected, as you can see it here on the right side. But this is to be expected. This is something that BIM has given us the opportunity to work with, which allows us really a lot of benefits. This is a very quick sample. You can see the color coding, which shows the deviation of each member compared to the expected. And based on this, we can plan our next steps, and we can modify maybe the pieces on site, on the ground, before we erect them, and waste time until we realize that they do not fit. This is a very nice example of integration between the point cloud and the real model. So you can see the colorized elements on the stand. For example, the purple are from the model, and the rest is the point cloud, which give us the opportunity to check whether everything is in order, and make the necessary changes for the next steps.
All right, now it's another example of the laser scanning, how it can be used in a construction project. We used to laser scan the whole site, so we were in a position to understand where we need cut, where we need fill, and this it was very effectively calculated through the standard tools that we have. Fanny, if you want to go to the next slide, and this is to be represented. Fanny, can you go to the next slide, please?
Yes.
Yeah. So, and this to be represented in a graphical way, so everybody understands and buy in with the requirements of the cut and fill, and being represented in drawings as well. Another very good example of the laser scanning is about getting the monthly progress on site using laser scans. These are not photographs taken by drone or scanned by drone. It's a standard laser scan on the ground. However, it depicts very effectively all the site conditions and how much we have progressed within a short period of time. Another function that we could use very efficiently is the tablets on site, the field BIM, the so-called field BIM, where the QAQCs, the health and safety, they can load, they can create and load their forms in tablets, getting the signature, and this optimizes the whole process. It has been kept in a database, paperless, and everybody has a view on the issues, key issues. And since it's electronic, we can have the flags, we can have a better understanding and better consuming of the information. It's not a dead document. Another thing that it could be very useful for the site and for the people that not that familiar with the BIM and that don't have the tools is having the BIM on their tablet. So they could load the project, they could navigate through the project, we could see some issues, they could raise comments, they could raise issues, warnings. The BIM, it's about bringing everybody in the same picture, all the parties. It's about enhancing the communication, it's about enhancing the collaboration of the different departments of the different teams, because as Fanny said in the start, it is really fragmented, and it is mostly what breaks and what hurts the whole construction is a communication, how everybody perceives something. If you don't have the actual material in front of you, you cannot take effective and informative decisions. So Fanny, if you can go
just to give another dimension, Nikos, I've noticed from our projects that once the implementation of this digital collaboration started on handheld devices, everyone was so thrilled and realized the benefits that they implemented them on their own, and they do not want to change and go back to paper and hard copies.
Correct. I cannot imagine any project now without having at least the basic BIM principles.
Correct.
Now, this is another tool that we pushed even further on this. We've managed to make the client have an understanding on the designs by having in the virtual reality, have them into the project, seeing the designs proposed and seeing the placement of particular elements have been placed in the space. And this increased the understanding and increased the effectiveness of the design. It's a very key element to be used collectively. Another very good use of BIM, it's the CDM. CDM, it's a term that is being used mostly in the projects in United Kingdom, construction design management. It's about bringing in construction and foreseeing it from the design point of view, all the risks and issues that we might have in the design. Again, this increases the understanding and prepares mostly the construction team about the hazard issues they might face. Of course, it's not about hazard issues, it's about reviewing construction methodology, how they're going to react, and these increased a lot of the understanding of the construction team to enhance further their processes. And of course, all these have been reflected in risk management and on the drawings where we placed a special target. So this target of the drawings correlates back to the the risk matrix. Fanny? Fanny, it's you.
Yeah, and I think BIM and 3D printing is like the new way of doing things. I mean, this is the future. I think it has major benefits, which we are only now starting to realize, like lower cost, lower waste, lower labor cost, minimized risk, and so on. Of course, we are still at the early stages. However, this will be further implemented in the future. And I mean 3D printing in real size. Obviously, now we can print models under scale, which we can use, miniatures. But in the future, I believe technology will give us the opportunity through BIM and through the information contained in the models to be able to operate these complex machines to do actual construction components on site. And of course, BIM is nowadays the basis for FM integration. All the information that we gather during the design and construction stage are now in the model as a central depository, right? Which helps us streamline the handover, which helps us integrate the information with the requirements from the operator or the FM team. And this is achieved through COBie, which is like the universal standard of communication between the database contained within the models and the other databases, which may be the operators or the client utilizes. And we can see here very quickly graphically how the models and other information like the O&M manuals or non-graphical information and documents are combined to form COBie, which is then helps create the asset information model with more input, of course, from other databases. And finally, this is being fed into the computerized maintenance systems, computer-aided facility management system, integrated workplace management systems, and so on. All these new type of software used for space management, maintenance, and asset management by the operators. And finally, of course, BIM is now the basis for the digital twin, right? With the digital revolution, Industry 4.0, as it calls, Internet of Things is everywhere. Like sensors are now everywhere. Building maintenance systems are present in all new projects, and these sensors are integrated with the information from the BIM models to form this, what we call digital twin, which is the combination of digital and physical world. And this will be, I think, the future. And of course, I have to say that operation is operation of buildings is an even bigger industry than the construction industry. And finally, just to put a little bit things into context with lean construction, of course, I will not read this, but just to identify the lean principles, identifying value, defining value stream, eliminating waste, work process flow, pool planning and scheduling, and continuous improvement. And I would like now to discuss, and I would like also from the audience to engage, whether with questions or remarks, how what is their point of view on how these can be served with BIM. This is a great slide from Abdulhamid. Just to give some context, Dr. Abdulhamid was the first one to give full lean construction principles and methods lecture, full course in Michigan State University in 2002. So I think his opinion is of great value, and you can see how he puts that IPD, integrated project delivery, which reflects the system optimization and the commercial terms, combined with Lean, which is the operating system, if we may say, planning inclusive of execution party, together with the technology, which is the technology branch of Lean, we can say is BIM, and finally the organization, where the previous command and control directives are replaced by a dialogue and collaboration, planning as an ongoing conversation. And here we can see the famous McLeany curve. This is true both for Lean and for BIM. The effort is front-loaded, and rightly so, because the preferred design process, which is the diagram number 4, the red curve, which comes earlier, give us the opportunity to impact the project with minimum cost, right? The later we put the effort, the less we can impact the design or the value of the project to the client and to all stakeholders, and the more expensive those changes become. And here you can see how Lean, IPD, and BIM, I would call it the new iron triangle, if I may, where system optimization, process and workflow optimization, and digitalization of design and construction information and data-driven processes can be combined to really improve the way the construction industry works. And just to refer to Lean Construction Management, which is the most great area in the middle, if I may simplify Lean into an effort between collaboration, simplification, and visualization, always referring to BIM, of course. And you can see marked in red the BIM uses and outputs. For example, in terms of collaboration, we can achieve real-time collaboration between stakeholders. There is transparency and better scope management, identification of constraints, consistent design and construction documentation, collaboration on handheld devices, big BIM room, right? There is BIM room and there is big room, but the trend is that this is now one shared room. For visualization, we have design coordination, VR, rendering, virtual prototypes. We are able to engage the client earlier and sign off the design, visual management, and construction sequence and methodology. And for simplification, all information maintained are in a single common location. Always the latest information are available, and they are available real time. And design and drawings and documentation are always extracted from one single source of truth, which is the BIM models. And finally, BIM, as part of Lean methodology and philosophy, can help to faster project delivery, better quality, cost savings due to reduced waste and less rework, better value for all stakeholders, and lower risk, of course. And finally, just to talk very quickly about BIM and return on investment, the image on the bottom comes from UK government and their studies. As per their opinion, BIM can save up to 50% of the design effort, up to 33% of the construction cost, up to 20% of the operation cost. And of course, this is a very big discussion, but this is how it is envisioned. And they have done a very big effort into doing studies based on different benchmarks. And there is now a tool, as you can see, top right, this blue one from Scottish Trust, Future Trust, where you can put your own project details, and you can, if we can say, quantify the expected return on investment from BIM implementation based, of course, on the degree of BIM implementation and the experience of the teams. And of course, many people, I think, might argue that there is a big upfront, front-loaded investment, both in equipment, in software, and in training. However, as you can see on the top left corner, this productivity loss is only for a while. And after this point, the productivity gain is there to stay. So this is really worth the investment. And I think from our experience, we have seen that implementing it on the go, really in the projects, not in training environment, is the best way to go, and it will very quickly be fruitful.